Have you ever written an answer in an exam, been absolutely sure it was right, and then lost marks? You're not alone. Well, today we're going to crack that code. We are going to get right inside an examiner's head by taking apart a real exam question and, way more importantly, its official mark scheme, because that is where the real secrets to scoring high are hidden.
Because that's the real game, isn't it? It's not always just about knowing the physics. It's about knowing how to present that knowledge in the exact way the examiner has been trained to look for. So today, we're going to reveal the secrets that are hiding in plain sight, right there in the mark scheme.
And this is going to be our guide. We're zeroing in on question 6 from an official AQA mark scheme. We're going to break it down piece by piece from those quick, easy 1-mark wins to the trickier 3-mark questions so we can really understand the rules of the game.
Okay, let's start at the beginning. These first few parts of the question are usually designed to be quick wins, but don't just brush past them. They teach us a really vital lesson about being precise.
So, the first part asks for the number of neutrons in a specific nucleus. Simple enough, right? You do a quick subtraction using the numbers on the paper. But the real question is, after you've done the math, what do you actually write down to get that mark?
This, just the number 148. That's it. Notice what isn't there? No words, no working out, no long explanation. The mark scheme is crystal clear. For this 1 mark, they only want the number. It's a huge lesson. Don't overcomplicate things, just give them exactly what they ask for.
All right, on to the next 1 marker. This time, you have to find which 2 nuclei from a table have the same number of neutrons. Again, it takes a couple of quick calculations. But what's the final answer they're looking for?
And there it is, D and E. The mark scheme shows that's all you need. These aren't trick questions. They're just checking if you can pull out the information accurately. Get in, write it down, get the mark, and move on. That's 2 marks in probably less than a minute.
Okay, time to level up a little bit. This next part is worth 2 marks. Now, that's a direct signal from the examiner. It means a single word or a number isn't going to be enough. You need to deliver 2 distinct, correct bits of information to get full credit. This one involved drawing on a diagram, and the mark scheme shows us exactly how those 2 marks are split. Mark number 1 is for getting the proton number right. Mark number 2 is for getting the mass number right. You see, it's not one big task, it's 2 small, separate ones. The examiner is basically saying, show me you know both of these things, and I'll give you both marks. And now, let's look at one of my absolute favorite things to find in a mark scheme. Question 6.4 reveals this super helpful little feature that proves examiners really aren't trying to catch you out all the time. The key word here is or. This is a gift from the examiner. It means they will accept either of these statements. They both get at the main idea that radioactive decay is random, but they're just phrased a bit differently. This gives you flexibility. As long as your answer lines up with the physics of either one of these options, you get the mark.
Okay, let's put all this together and tackle the big one. We're at the final part of question 6, the 3-marker. Now, I know these longer questions can look a little intimidating, but the mark scheme gives us the perfect blueprint for how to build a full mark answer.
So here it is, the full entry from the mark scheme for 6.5. At first glance, it kind of looks like a wall of text, right? But look closer. It's actually just 3 separate ideas, all stacked on top of each other to build one complete logical answer. Let's break it down. This shows you the structure of a perfect 3-mark answer perfectly. Think of it as a chain of logic. For your first mark, you state the effect of the alpha decay. For your second mark, you state the effect of the 2 beta decays. And for your third mark, you bring it all together for the final conclusion. You get a mark for each correct link in that chain. But wait, there's a catch. Check out this note in the extra information column. This mark is dependent on scoring the first 2 marks. This is so important. It means you can't just jump to the end conclusion, even if you know it's right. You have to earn that 3rd mark by correctly laying the groundwork with the first 2 points. So after this deep dive into just one question, what's the big takeaway? What are the key rules of the game that can help us all start thinking a little bit more like an examiner?
Here it is, your new exam checklist. Number 1, be precise. Don't write a novel when a number will do. 2, always hunt for the word or. It gives you options. 3, break down the marks. A 3-mark question needs 3 separate points. 4, always read the extra information for hidden rules like those dependent marks. And finally, number 5, use their language. Using the same scientific terms as the mark scheme leaves absolutely no doubt that you know your stuff.
So remember this, a mark scheme is not just a tool for teachers, it's one of the most powerful revision tools that you have. It's literally the blueprint for a perfect answer. The only question left is, now that you know the rules of the game, how is this going to change the way you prepare?